Okay, so this brings us to how we represent atoms when we're talking about their atomic structure, when we're talking about how to represent them in a chemical reaction or in a nuclear reaction. How do we do this without having to write down paragraphs explaining all of the things that are going on with that atom? So we do that in chemistry with symbolization. All right, so we are going to symbolize our atoms, and it's going to give us all the information we need to know about that atom. It's going to tell us what its symbol is, what its mass is, what its atomic number is. It's going to tell us a bunch of things. And it's all done in a very short, compact method that we're not writing paragraphs explaining about the atom. So the first thing that we're going to look at is how to draw or write the nuclear symbols for the atoms of interest. So I have a sample atom up here at the top corner that I went ahead and already wrote down. We're going to look at the sodium atom. And the sodium atom, this particular atom, has 11 protons. Okay, that's what the P stands for. 11 neutrons and 10 electrons. So we're going to represent this atom in a nuclear symbol so that we have all of that information in a real compact place for when we're looking or observing it, how it reacts, and that kind of stuff. All right, so the first thing we need to do is we are going to write it in the form that is shown below. So this layout here is how we represent atoms using the nuclear symbols. You can see here we have the X. That big X represents the elemental symbol. It's found on the periodic table. It is either a 2-letter or 1-letter symbol. Not all of them kind of at first make sense. So if you look at sodium, it has Na. So a lot of the symbols that they derived for each of these elements came from their Latin name. We're not going to get in to what all of their Latin names are, but that's why some of their symbols don't match up with their actual name. So Na is the symbol for sodium. So if we're going to write this in its nuclear symbol, we're going to put Na in the center, just like the X is right here. All right. The next thing we're going to do is we're going to include at the top the Z. So the Z represents something called the mass number. The mass number in an atom is the mass of that particular atom. So remember that the mass comes from only 2 subatomic particles. It comes from the proton and the neutrons that are housed in the nucleus. Because remember, the nucleus is very small and it doesn't take up much volume in the atom, but it makes up all of its mass. So to find mass number, all you are doing is adding the number of protons with the number of neutrons, because that is what is housed in the nucleus. So mass number is representing that weight of the nucleus. So only the things in the nucleus can be added to get the mass. Okay, so mass number is protons plus neutrons. So for the particular atom we're looking at, we are dealing with 11 protons and 11 neutrons. So that means its mass number is going to be 11 plus 11. So we are going to have a mass number for this particular sodium atom as 22. So I'm going to put that as a superscript in the upper left-hand corner. All right, so the next thing we need to add is the A. Okay, now the A represents the atom's atomic number. Now, if you take a look at your periodic tables, you will see that the atomic number is it'll either be in the upper right-hand corner. On some periodic tables, they're right smack dab in the center, and then other times they're going to be below the atomic symbol, right there in the center. Okay. So one thing you'll notice is that each element is assigned its own atomic number. And if you change the atomic number, you change the element. This is a very important piece of information that you need to keep in your brain. It needs to be something that's locked in there, because the atomic number represents the number of protons that are found in the nucleus. So if you change the number of protons, you change the element. So theoretically, we could take any element and we could change it into gold by just making it have 79 protons. So that's theoretical. We're going to get into why that's not super feasible, why it's not something that we do, because it takes a lot of energy to do that. And we're going to discuss that as we're moving through the atomic structure. But the number of protons is going to give the identity of the element. So if you change that number, you change the element. So the atomic number for sodium is 11, okay? When we're looking at this, remember, okay, that's also how many protons that element has. So sodium has 11 protons, which is its atomic number 11. So we write it right below the mass number. Now the next thing you can see here in the upper right-hand corner is the charge. So how do we get charge? Okay, well, charge is really easy to find because all you do is you take, to find charge, you are going to take the number of protons and you're going to subtract it from the number of electrons, because remember when we discussed about the subatomic particles of the electron and the proton has a +1 charge and the electron has a -1 charge. So they are going to cancel each other out to make a neutral or zero charged element. So if I have an odd number of protons or an odd number of electrons, it's going to give the overall charge of an atom its positive or negative charge. So it's going to create these things called ions. So in this case, if you look for charge on this sodium atom, there are 11 plus charges in the nucleus, and there are only 10 negative charges in the electron cloud. So what happens is it gives this atom an overall positive +1 charge. So I can write it like this. Now sometimes you will see when we write charges, especially when it's a 1, sometimes that 1 is understood. So sometimes you're going to see it written just like that because that 1 is understood. All right, so that's how we calculate charge. We are going to look at the number of protons versus the number of electrons. And if there's different numbers with that, we have a charge. So that is how we write nuclear symbols for atoms. Now, one of the neat ways when we're looking at this is when you're looking at a nuclear symbol like this, it's very easy to determine how many neutrons are already in that atom. So if I was not given the information up here, I could figure out all of that information by just looking at this atomic symbol because everything we need is right there. All right, so let's look at this. So if I wanted to know how many protons, neutrons, and electrons were in this atom here, first off, the number of protons, well, that's easy because remember that is always the atomic number. So that number always matches the number of protons that you have. So that would be 11. With neutrons, well, neutrons are housed in the nucleus with the protons. So I know I have 11 protons. I know that the mass of my nucleus is 22. So if I take the number on top and I minus it from the number on the bottom, that's going to tell me how many neutrons there are. So this tells me right here. To get that, I just take the mass number and I'm going to minus it by the atomic number. And that will always give you the number of neutrons found in that particular atom. So 22 minus 11, I have 11 neutrons. Now for electrons, the charge is going to tell me that. The charge is going to help determine how many electrons. The charge, again, tells you that I took the number of protons and I minused it from the electrons. Well, if I have a +1 charge, that's telling me right there that I have one more proton than I do an electron. So you could either plug it in to charge is equal to proton minus electron. You could plug it in and solve that way. Or you can just think about it in your head. Well, if it's a +1 charge, there's one more proton than there is an electron. If I have 11 protons, that means I'm going to have 10 electrons. Okay? We're going to do some more practice with this later on.